In this lesson, we're going to identify the GCF of numbers and to identify the GCF of terms. Favorite ethnic cuisines. Now, I can't see you, my audience, but if I were to survey you and ask you, what is your favorite food preference? How many of you like Italian foods such as pizzas and pastas and so forth? How many of you like seafood? Mexican foods? Asian foods? Indian? Spanish? Mediterranean? Soul food? And how many of you are vegans? Now, if I could see you, I'm pretty sure that quite a few of you had several food preferences that you had in common. And then there were some of you who probably shared little to no common favorites in foods. The greatest common factor, often referred to as the GCF, is the greatest integer that is a factor of two or more integers. In this example, we're asked to determine the GCF of 24 and 30. In other words, I want to know what is it that 24 and 30 have in common. What is it that they share in common? Well, they might share a lot of things, but I want to find the GCF. I want to know what is the greatest common factor of those numbers. So one way to do that is just simply find the product of those numbers. In other words, what two numbers, when I multiply them, will give me 24, and what numbers, when I multiply them, will give me 30. Well, we know that 6 times 4 is 24, and 6 times 5 is 30. So we can see here that these two numbers, they do have something in common. And they actually have a lot of little things in common, sort of like the ethnic foods that we talked about. Some of you had several foods that you had in common, and then some of you had very little to no foods that you had in common. If we were to break 24 and 30 down further, we can see that they have 2's in common. They also have 3's in common. In other words, each one of them has a 2 inside the number. Each one of them has a 3 inside the number. We don't want all the little things that they have in common. What we want is the greatest thing that they have in common, and that is called the GCF, the greatest common factor. So the greatest common factor of 24 and 30 is 6. So therefore 6 is the GCF. Now is your turn. I want you to determine the GCF of 72 and 80. So if you'd like, you can pause the video for a moment and see if you can identify the GCF of these two numbers. Now again, they may have a lot of little things in common, such as a 2. Inside 72, there's a 2, and inside there's a 2 also in 80. I don't want those little things that they have in common. I want you to identify what is the greatest integer that these two numbers have in common. Okay, so I know that 8 times 9 is 72, and 8 times 10 is 80. So I can see here that yes, although they have a lot of little things in common, the greatest integer that they have in common is an 8. So therefore, 8 is the GCF. Now let's find the GCF of terms. The GCF of two or more monomials is the greatest common numerical factor and the least power of the common variable factor. For example, we are given to find the GCF of 6p, 4p squared, and 8p cubed. So again, step one would be to write them as products. In other words, for the first term of 6p, 2 times 3 is 6, and I have 1p. For the next term, I can break that down as well. 2 times 2 is 4, and I have 2p's. And you do the same for 8. And then you want to look at the three terms to determine their common factor. In other words, the GCF, the greatest common factor. And to find that, for the numerical part, it is going to be the greatest common numerical factor. So, looking at our numbers, we want to know the greatest number that they all share in common. Well, everybody has a 2, and at most only one set of 2's. So the GCF would be a 2 in terms of the numerical factor. Now, if that first term of 6p had one more 2 in it, then they may have shared something other than just a 2. But in this case, everybody has a 2, and so it is only the 2 that they all share in common. Notice everybody does not have a 3, so 3 cannot be part of the GCF for the numerical factor. Now let's look at our variables. We want to know what they share in common. So we only have one variable here, and that's a p. We want to know at most how many p's does everyone have in common. Another way of looking at it is the least power. Out of everyone, who has the least power for the p? And that would be your first term, because your first term has a power of 1 for the p. The second term has a power of 2. The third term has a power of 3. You always go by the least power to determine your GCF, because you know at most everybody does have at least one p in common. So when you put it together, then your GCF would be 2p. And now is your turn. I want you to see if you can find the GCF of these two terms. So take a moment, pause the video, and see if you can identify it before the answer is revealed. Okay, so step one would be to look at your coefficients so that you can identify what is the GCF among those two numbers. So our coefficients are 7 and 21, and you want to know what is it that those two numbers share in common at most. And if you break them down into products, 1 times 7 is 7. 3 times 7 is 21, and we can see here that these two numbers share a 7 in common. So therefore, in terms of the numerical part, 7 is the GCF. Now let's identify the GCF of the variables. So recall, you're going to look at your variables, each one at a time, and determine which variable has the least power, and that would be your GCF. So looking at our m's, we want to know which m has the least power. So for the first term, it has a power of 6. The second term has a power of 5. This is the smallest or the least power for the m's, so that would be 5. Next, we want to look at our n's, and we want to determine again which one has the least power. So of the first term, it has a power of 1. The second term has a power of 4. So the least power would be 1. So putting it all together, your GCF then would be 7m to the 5th power n.